If you're making a 2D game in Unity, chances are you're going to need a player controller to move around your player. My name is Tom, and in this video I'm going to show you how to make exactly that. So you can make a player controller in a variety of ways. First of all, you can move the position of the object directly. This is the most simple way to do it, but it doesn't work with physics. The second approach is using Unity's built-in character controller. The character controller makes it easier to climb up slopes, for example, however, it doesn't include gravity support. And then the method we'll be using is a rigid body. This already comes with gravity, and you can use features such as forces to act on your character, for example if something explodes. So let's jump right into the tutorial. So as you can see, I've set up an example scene for us. We've got our player in the center and a simple tile map level around us. The assets I'm using, by the way, are on screen now. Pixel Adventure 1, I just got it from the assets store. Now in this tutorial, I'm going to be using Unity's new input system as opposed to the old input manager. That's because it's newer and it's much more flexible than the old system. So to install it, you want to head over to the package manager, which you can open window package manager. You want to set packages to all if it's not already, and you want to find input system. So you might get a pop-up asking if you want to disable the old input manager and use the new input system. If you see that, click yes, and Unity will restart. If you don't see that pop-up, head over to project settings. You can open that with edit project settings. Go over to the player tab, other settings, scroll down until you find active input handling and set that to the input system package. And you'll probably have to restart the Unity editor for this to take effect. Once that's done, we need to actually create our input actions asset. So right click assets, create input actions, and we're just going to call it player controls. We'll double click it to open it up and we see this window. So the new input manager allows you to easily add new actions and customize the buttons which activate it. So we're going to head over to the top left here and click no control schemes and click add control scheme. We're going to call this one keyboard, and this control scheme requires a keyboard. And then we're going to click save. We're now going to create an action map and we're going to call it player. And this will house all of the actions related to the player. We can see that one action has already been created for us. I'm going to double click the name and rename it to jump. And if we open this up, you'll see that there is an empty binding here. And this is the button that will actually activate the jump action. So once we've selected this empty binding, you can go over to the right in the properties section and see this drop down next to path. If you click that, and click the listen button, you can now click any key on your keyboard or any controller or any other devices you've got plugged in that you want to use for jumping. So I'm going to press the spacebar and choose space keyboard. So that is our action for jumping. Now we're going to add one for moving. So we're going to click the plus here and we're going to call it movement. And for movement, I want to use A and D for left and right and the left and right arrow keys. So we're going to click the add here, add a 1D axis composite, and we're going to call it AD. As you can see, we've got a negative and positive section. So positive is D, which would be right. So we're going to click path, listen, and press D. And negative is left. So we're going to press path, listen, A. We can delete this empty binding here, and we're going to create another 1D axis composite, and we're going to call it arrows. The negative will be the left arrow, and the positive one will be the right arrow. So that is our input action setup. So all we're going to do is click save and close the window. And to actually access this in code, we need to click the player controls asset, generate C# class, and press apply. After a couple seconds, you'll see a player controls script here, and this is what we'll actually use in C# to control our player. So on our player object, we're going to click add component and add a Rigidbody 2D. We're also going to add a collider, so I'm going to use a capsule collider. Make sure that's 2D variant, and we're just going to resize this to fit our player now. So the size, I think we want maybe 1.25 on the X and maybe 1.5 on the Y, and we're going to lower that down a bit. So now that our collider looks like it fits the player pretty well, we're going to click add component again, and we're going to type player controller. Click new script and create an add. So we're going to open that script up in Visual Studio. So here is our empty script file, and we're going to need a couple variables that will control the speed of our player. So we're going to have a public float for the movement speed, and a public float for the jump strength. Next, we're going to need a reference to our rigid body, so we're going to have a private rigid body 2D RB, and then we're going to have a private void awake to actually get the Rigidbody reference like that. And the reason we use awake is just because it's called before start. So if we needed to use Rigidbody in start, we could. You can also just put this in start. It really doesn't matter. So now we need to set up our controls. So underneath the Rigidbody, we're going to have a private player controls. And in the awake function, we're going to create a new player controls and assign it to the controls variable. And here we actually set up what we want to do when we press the buttons. So if we type controls.player, we can see player here is the name of the action map we created. And if we press dot again, you'll see jump and movement. And this is the name of the actions we've created. So we're going to start off with movement. And for each action, you've got several events. So you can have cancelled, performed, or started. So for movement, we're going to use performed. And the syntax for this may look a bit strange, but we need a plus equals. And this is actually adding to what happens when movement is performed. So we're going to pass in a variable called CTX, stands for context, and this will contain the information about how the keys were pressed. We're going to have a equal sign and a greater than sign to form this arrow, and we're going to need a variable to store the value here. So we're going to create a private float called movement. And now after this, we're going to set movement equal to context.readValue, less than sign, float, greater than sign, and brackets, and a semicolon. So basically, when the movement action is performed, we add on to it this, which is going to be performed, which basically sets the movement to the float value from our input action. A bit confusing, but it does make sense. So we're going to create a private void fixed update now to handle our physics. So I'm going to be editing the Rigidbody's velocity manually. However, you could use add force if you wanted to. So we're going to do rb.velocity equals a new vector2. On the x, we want movement times by movement speed. And then on the y, we just want rb.velocity.y. So it doesn't interfere with our jumping. So after this, we actually need to enable our controls, and I'm going to do this on the onEnable and onDisable functions. So we're going to have a private void onEnable, and since we're just having one thing, you can actually replace the curly brackets here with just this arrow, and we're going to do controls.enable. And the same thing for private void onDisable, you can do controls.disable. And now if we save that and go back into Unity, so back in Unity, we've got to set the value of our movement speed. So I'm going to choose a value of 10 for now. And if we hit play, you'll see that using A and D, or left and right arrow keys, will in fact move our player. However, you've probably spotted the glaring issue that our player is rolling about. So to fix that, we need to go to our Rigidbody and freeze the rotation on the Z-axis. That will stop our player from rotating. However, there is still a slight problem here. If you press one of the keys, you cannot stop the player, so it just continually moves in that direction. So to stop this, we're going to do controls.player.movement, and we're going to use .cancelled here instead of performed, plus equals. We don't actually need context here, so we're going to use a underscore, which is a discard, so you don't really use this variable. We're going to do the arrow again, and we're going to set movement equal to 0. Now in Unity, if we use the left and right arrow keys, you can see that our player is moving, and when we let go, it stops. However, you'll also see that the player doesn't actually flip direction. When we go left, it's just always facing right. And to fix that, I'm going to go into update here. I'm going to go into the update function here and check if movement is less than 0. So if we're moving left, then we're going to set transform.localScale equal to a new vector3. -1, 1, 1. So -1 means it's flipped. Else if movement is greater than 0, if we're moving right, transform.localScale equals a new vector3, 1, 1, 1. Now if we go into Unity and hit play, you can see that moving right faces the right way, and moving left also faces the right way. Next, we're going to move on to jumping. So back in our script, we're going to create a private void jump, and this is simply going to set our velocity equal to a new vector2 with rb.velocity.x on the x to avoid messing around with our movement, and the y velocity is going to be jump strength, like that. So now we need to assign this function to our jump action. So we're going to do controls.player.jump. I'm going to use started here, plus equals underscore arrow jump. So back in Unity, we need to choose the jump strength for our player. So I'm going to choose maybe 15 and hit play. And as you can see, we can now jump. However, that's a bit high, isn't it? So one fix for this would be to obviously turn down the jump strength to 5. However, this makes the jump pretty slow. To fix this, I'm going to actually bump up the jump strength again and change the gravity scale on our Rigidbody to something like 5. Now we can see that the jump's a lot faster, it just looks better, and it jumps to about the right height. So go out of play mode and remember to change the gravity scale again. And there is one final issue we've got to resolve, that is you can jump indefinitely into the sky. So to fix that, we actually need to create a tag. So you need to select all the objects you want to use as a ground that you can stand on. So for me, that's base and platforms. You need to click the tag here and click add tag. You want to click this add here and call it ground and click save. Now go back to your base and platforms and set the tag to ground. Now back in our script, we're going to add 2 new functions. We're going to do on collision enter 2D and on collision exit 2D. So inside of on collision exit 2D, we want to do if collision.gameObject.compare tag to ground. So if this game object is tagged with ground, you may be tempted to do collision.gameObject.tag equals ground. However, this is actually less performant and it's slower than this, so you should always use compare tag. So if we have just left the ground, we want to set is grounded to false because we've just left it. And we actually need to create this, so we're going to go up to the top, private bool is grounded. So inside of onCollision enter 2D is when we actually enter the ground again. So if collision.gameObject.compare tag ground, then is grounded is equal to true. And now in the jump function, if we are grounded, we want to jump. And if we are not, we want to do nothing. So after making those changes, we should be able to go into Unity and press play, and we can only jump once we are on the ground. As you can see, I'm pressing spacebar multiple times, but I'm only jumping once. Now, a final tip to fix issues like this, your character getting stuck on the edge of blocks, you need to exit play mode, go into your assets and create a physics material 2D, and we'll just call it player, and we need to set the friction to 0. Now, if we go into our player and add this player material to our collider and hit play, we should see that we no longer stick to the edge and we just slide past it. So that's it. We now have a fully featured 2D player controller. We can move left and right and we can jump. And if you wanted to adapt this to maybe a top-down game, you could simply go into the player controls and change movement here to a value and set it to a vector 2. And now you can actually add a 2D vector composite, and this will allow you to use up, down, left, and right. You could then, in your script, the same way we've done this, instead of reading a float, you could read a vector 2, and you could modify the velocity in the X and Y. So if you found this video helpful, please leave a like, and don't forget to subscribe. You can also turn notifications on so you never miss another video. But thank you for watching, and I'll see you in the next one.